So carbon and hydrogen, carbon plus hydrogen. This is okay. There is no problem at all. But this is the one chapter. Why do we study? What is the reason of this? Why do we study? Do we study?
Yes.
Ah, this is the question. What the advantage? The first thing, this is the they are fuel. They are the fuel. Nay, that is component of what component? Component of LPG, liquefied petroleum gas, CNG, compressed natural gas, LNG, liquefied LNG, liquefied natural gas, LNG.
Yes, sir.
They are the component of this one. Now, they are also part of what? Part of what? That is food items. Food items. Okay, food items. Like if you see the what we are what we are eating, that is they must be having the carbon and hydrogen. Basic things, the carbon hydrogen. Suppose you can see the glucose. So it is there. What is C6H12O6? Mostly what is there? Carbon and hydrogen. If you are taking sugar, okay. So what you are trying, that is C12H22O11. What are the most of the part of the what are there? That is the carbon and hydrogen. That is why all organic compounds contain what? Contain one things, carbon and hydrogen. This is the essential element, carbon and hydrogen. Mostly it should be the carbon and hydrogen. And what we eat, what we wear, this is all about the organic compound. Now, let us go back and see the NCRT, what the NCRT is saying. Here you see. So if you see the NCRT, these terms are there here. Okay. So I am reading the line by line. We are going because some applications are being asked nowadays. So here you see in this case what the point they have given. The term hydrocarbon is self-explanatory, which means compound of carbon and hydrogen only. The word is used what? Only. That is important. Hydrocarbons play a key role in the daily life. Why? Because the term LPG, CNG as a fuel, we are using that is LPG and CNG as a fuel, that is hydrocarbon. LP is the abbreviated as the liquefied petroleum gas, whereas CNG stands for the compressed natural gas. Another term is there LNG, liquefied natural gas, is also now a news these days. Now see what is there here. This is also fuel and is obtained by the liquefaction of natural gas. What are the natural gas? It can be the CH4. Okay, now
Yes.
here you see petrol. One thing, what is there? Petrol. Second is diesel. Third is kerosene oil, are obtained by fractional distillation of petroleum found under the earth crust. They are the what the component, this is they are found in the earth crust. Now another thing you see, coal gas is obtained by the destructive distillation of coal. Natural gas is found in the upper strata during the drilling of the oil. Natural gas means what is, if you are studying, this is suppose it is the earth or the you can find this is the ocean. So what you find in the bottom, what are there? There will be the gas is there, gas. And below that, what is there? Liquid petroleum, liquefied petroleum. Okay, petroleum. So they are if this is the earth or the liquid, it can you will find. Here you see the gas after compression is known as compressed natural gas. Compressed natural gas means that is CNG, you know. LPG is used in the domestic fuel, that is also hydrocarbon with the least pollution. LPG, there is a very less pollution. Kerosene oil is also used as a domestic fuel, but it contains some pollution. So kerosene is having pollution. Automobile needs a fuel like petrol. Automobile needs a fuel like petrol, diesel, CNG. So this is the petrol and CNG operated automobile causes less pollution. All these fuels contain the mixture of the hydrocarbon, which are source of energy. Hydrocarbon are also used in the manufacturing of polymers like polythene. polypropylene, polystyrene, etc. Higher hydrocarbon are used in the solvent like the pen. Okay, so where they are being used, you can see here. That is the one thing, the polymer also there. What are the polymer? You can see this one. Here you see polymers. What are the polymers like that? Polythene. Polythene is what, Sanu? That is ethene is there, ethene. And n number of
Yes.
ethene you are combining. So it will give the polythene, CH2, CH2. Here it will be the N. So this is the plastic bag, polythene. Next one is they are saying polypropylene. Polypropylene. What is polypropylene? Here is CH3 there, CH2, not C. If you see CH2, then CH, here is CH3. This is also polypropylene. This now, this cannot be correct one. Wait. Here. Polypropylene also made like that. CH3 is there, na? C, H, double one CH2. So take N number. So how it will be? CH, it will be there CH3. Here is CH2. So this is what is the called polypropene. Okay, polypropene. This is the 1, 2, 3. Propene is there. Now how it is polymerized? Polypropene is like that. Okay. Next one is polystyrene. Polystyrene structure is, if I will make, let us see the polystyrene. Here is CH, double one CH2. So N number you take, this will be what will be going to be like that. C, here is CH, this is. Here is CH2, this is. So N time. So they are the polymers like the clothes we are wearing, table, chair, many things are there. They all you are finding what they are the hydrocarbon, nothing else. They are also used as the starting material for the manufacture of many dyes and drugs. Thus, you can well understand the importance of hydrocarbon in our life. In this unit, you will learn about the hydrocarbon. So first one, you see the classification. So classification you must be knowing very well. Let us do the classification. Can you tell me the hydrocarbon classification? Tanmay? Hello.
So saturated and unsaturated aromatic.
Classification of hydrocarbon. Super. Correct. Okay. So what is there? First one is they are writing open chain. Open chain. Second one, closed chain. Open chain, there are two types are there. Saturated, that is what is there. Unsaturated. Saturated, unsaturated. Unsaturated are two types. And first one is alkenes, and second one is alkynes. Okay, and here is alkanes, ALKANE. Now closed chain. Closed chain also two types are there. Okay, types of one. If you talk about the alicyclic is there. Here, that one. Alicyclic. Okay, and second one is aromatic. Aromatic are two types. First one is bentonite. Then second one is non-bentonite. Alicyclic are those there. Okay. What are the alicyclic? If you are talking about, this is also two times. That is called, one is called what? Saturated alicyclic. Saturated. Okay, and this is the unsaturated. Let us go one by one. Okay, saturated means there should be the single bond here. Unsaturated, it should be somewhere double bond. Like if you are talking about some more, you see the one more. Here is there. This is the alicyclic. No, 930. Second one is what is there? Here is the ring. So this is unsaturated. They are although cyclic, but here is what their properties are like that. What you are finding, that is there is no double bond, is single bond is there, this one. It can be like that. One more compound if you are writing. First of all, you should understand what is the alicyclic and aromatic. Aromatic, the long topic of discussion. Here, saturated, you know very well. What is the single bond is there? Unsaturated, either double or it can be triple bond. Here, general formula is CnH2n plus 2. Here is what is there, CnH2n. Here is CnH2n minus 2. Now, we are going for the aromatic. Okay. So here you see aromatic hydrocarbon. This topic is taught to you, na? Aromatic hydrocarbon. This topic taught to you or not in the school?
No, sir.
You said that they are teaching hydrocarbon.
Today they taught the reaction, sir. Sir, yesterday they taught the ozonolysis, that one, sir.
Huh?
That how one aldehyde, sir. How that oxygen bonds we are breaking, sir. Like, sir, one will be like this. So, let me show you. Sir, one will have this one like.
Hello. हाँ समय.
Sir, one.
Those compounds which follow.
Sir, this one. Sir, and the other end that will be also, sir, aldehyde one.
Okay.
Sir, and these two they will be, sir, eliminating. So now this will form something
No,
like
so
this.
they are not going thoroughly or what? From the first topic, they are taking a random topic or what?
Sir, actually, this organic compound and hydrocarbons. So these two chapters, na, a little bit mix up is there.
Okay. Those
Sir, we
compounds.
are doing serially only, so that is only better, sir. As per me.
See the aromatic hydrocarbon. Those compounds which follow aromaticity, rule of aromaticity. What is their rule of aromaticity are called. What you are calling that one? Are called aromatic compound.
The rule of aromaticity is known as Haeckel's rule, na?
Yes. Okay. There are four rules. So if you are talking about rules of aromaticity, there are four rules, not the only Haeckel rule. Aromaticity. Okay. What are the four rules? You tell me the please first one. Can you tell me? Compounds should be cyclic.
Could not be saturated.
Compounds should be cyclic. Second one, could not be saturated. That is correct. Compounds should be planar. Planar. That is sp2 hybrid. It should be sp2 hybrid. Third one. Compound should have conjugation. Compound should have conjugation. What is conjugation? Can you tell me? In the resonance, I told you. Conjugation. Compound should have conjugation. Means single.
Another one is the 2n plus 1 rule. 2n plus 2 rule.
This is the first condition. Second condition you can see. Single, double, lone pair electron. Third, single, double, negative charge. Okay. Next, single, positive, negative. Fourth. Are you getting? Anything should not get repeated. Okay. And anything should not get repeated. Okay. Now, fourth one. Compounds should have conjugation. Fourth one we are going. What we can say? Compounds should follow. Compounds follow what rule? Compounds should follow what rule? Haeckel rule. Huckle. Haeckel rule. Haeckel rule. Right? Compounds should follow Haeckel rule. 4n plus 2 pi electron rule. Pi electron rule. Where what is there? Where n is equal to number of benzene ring. Number of I benzene ring. Okay. Now, so these are the rules. You should know. Compound should be cyclic. If it is acyclic, this not be aromatic. Impossible. Compound should have planar. Planar means two hybrid. Compound should have conjugation. Any of the conjugation. Some more also possible. There no problem. Compound should follow Huckel rule 4n plus 2 pi electron rule, where n is equal to number of benzene ring. So now apply. Here we are having this compound. Okay, firstly let us try to understand Huckel rule. Otherwise you will mix up with the problem. Huckle, Huckel rule. Huckel rule means 4n plus 2. This is going to be pi electron rule. Okay. N is equal to number of benzene. Okay, number of benzene ring. Suppose if case one, if number of benzene ring is zero. If number of benzene ring is zero, so n equal to 0. Okay. From formula, you go 4 into 0 plus 2 pi electron. So how many? 4 into 0, that is 0. 2 pi electron. Okay. 2 pi electron. For example, here is the, can you see it is in the conjugation or not? Conjugation is there. This is the pi sigma positive. So everything is alteration, yes or no? Pi sigma positive. So what is there in this one? What is there? This is the conjugation, yes or no? So, so how many pi electron are there? This is the one. Here is one bond means 2 electron. So it is having 2 pi electron. Yes or no? One double bond is there. Now one double bond means 1 sigma 1 pi. So that is this one. Now this one is the
Each pi bond will have 2 electrons.
So this is the what this compound is aromatic, because this is the sp2 hybrid, all carbon is sp2 hybrid. It is second one is cyclic is there, and third one is Huckel rule. It is Huckel rule, and fourth one is conjugation. All the rule it is following. So it is going to be what?
So aromatic.
Aromatic. Okay, super. This is what is aromatic. Now going for the next one, case 2. Case 2. If n equal to 1, that is one benzene ring. Should be one benzene ring. So if the number of benzene ring is 1, so what is there? From the rule, from formula, you go formula.
Sir, 6 will be there. 6 pi electrons.
Super. So 4 into 1 plus 2 pi electron. So it is going to be 6 pi electron. So this is the 6 pi electron. So 6 pi electron you can find, this is the benzene.
Yes, sir. 3 bonds and 3 into 2, 6 electrons.
This is 1, 2, 3, 4, 5, 6. So first one is this compound is the cyclic, correct? This is the conjugation is there. Conjugation. What type of conjugation is there? Double bond, single bond, double bond. Okay. This is. And third one is there. After conjugation, what you are going to find? This is the
I'm not able to hear what you just told.
NR. This is full NR. sp2 hybrid. And it is also following the Huckel rule. So Huckel rule is also following. So all the rule it is following, it means it is what going to be aromatic compound. Yes or no?
Yes.
Okay. See, the case 3. Case 3. If n value is equal to 2, so what is from formula? From formula. You are going from formula. 4n plus 2, it is going to be pi electron. So 4, n value is 2 plus 2 pi electron. So what is
10
there?
pi electron.
10 pi electron. So this is also, can you compound out this one? Anthracene I am giving you. This is the anthracene.
Sir, anthra what? Anthracene.
Anthracene. This is the sublimable substance, volatile. So is it the aromatic or not? That it is. Yeah.
So, sir, cyclic is there, conjugation is there.
Hmm.
These are the planar only.
Hmm.
This is also aromatic only.
Acha. So how many pi electrons are there?
The total 10 pi electrons are there.
Hmm.
The 6 double bonds into 2. No, 5 double bond into 2. 5 to 10.
Hmm. 10 pi electrons. So everything is there. Everywhere double bond is there. So sp2 is there, means planar is there. Cyclic is there. Conjugation is there. Okay. And that is 10 pi electron. So Huckel rule also following. This is the, okay. So this is now you understood the aromatic compound. Okay. Now we are
Sir, I
going.
have one doubt. If
Uh,
you are given a carbon compound, sir, for example, I will take benzene only.
uh,
Sir, benzene looks like this. Sir, you have this one.
hmm,
Right, sir, these two double bonds are there.
hmm,
Now,
hmm,
once you are told you to find out the hybridization of this carbon,
hmm,
sir, how you know that this is sp2?
hmm. Hybridization means this one. Hybridization means, okay, either you go number of sigma bond, okay, no pi bond, pi bond are the formed by non-hybrid orbital, okay, this is double non-hybrid orbital. So either you see number of sigma bond, okay, non no pi bond, this is the pi, no pi bond, or hybridization you can also do. Hybridization, how can you look hybridization? Number of sigma bond, plus lone pair electron, or one other is there, number of sigma bond plus what is negative charge. So Sanmay, check
Sir,
that.
how will you do in this case, sir?
That is what I am going to tell you. This one. Everywhere there is hydrogen, yes or no?
Yes, sir.
These are. Now, what we are talking about, that is one pi bond, one double bond. Agar you are having one double bond. So in double bond, how many sigma, how many pi? Pi. One triple bond. How many sigma, how many pi?
So 2 sigma 1 pi.
Here you are saying that is 2 sigma, 1 pi. This one. But this is wrong.
So then I think this should be 1 sigma.
Okay, go C2H2. So C2H2, it is going the sp hybridization. Okay, because each carbon required the one bond here. This is the center one is what? This center one is sigma bond. Up one is, down one is pi. How it is formed? How? Carbon, carbon. So this is the head to head overlapping. Here is the hydrogen overlapping. These are the what? Hybrid orbital. Okay, hybrid orbital. But it is having 2 pi. So 2 pi, this will be the one unhybrid orbital double shape. This is another unhybrid orbital double shape. This is double shape. This is double shape. So what it will be there? Here side by side overlapping is there. These are the side by
Sir?
side overlapping. Here you will find this is the, here is also side by. So this one is head to head overlapping, that is sigma bond. This is side by side overlapping, what is pi? Pi. So how many pi are there? 2 pi. Upside, downside, two places it overlap, the one find pi bond is formed. So if I will take double bond, so one is sigma, one is pi. If I will take triple bond, pi, pi, sigma. Center one is always sigma. Can you understand?
So last part did not follow. Sir, once again, please tell.
Here na, the middle one is na, middle is possible head to head.
Yes,
It will be the sigma bond. But these are what? Side
yes,
by side na, overlapping this one. They are the
mm,
pi bond.
yes.
Now come back here. So what the rule you are going to apply here? Here. What is the rule? One is the sigma, 2 pi. Here is what is there? Double bond. 1 sigma, 1 pi. Can you understand? During hybridization, I taught you. I think you forgot everything. That is there in the concept of hybridization. Now,
So middle one is sigma.
middle is always sigma head to head. Now go this one. In this compound, what is the number of sigma bond? Can you tell me? With this carbon, each carbon you go, how many number of sigma bond? Tell me.
So this one will have so three sigma bonds. No, these are 6 sigma bonds.
Each contain each carbon
Yeah, sir, I made
contains
a mistake. Each carbon will contain three sigma bonds.
3 sigma bond. 3 sigma
Yes,
bond. The C sigma bond is
yes,
one s orbital, 2 p orbital, sp2. 3 means what? 1s, 2p. If all are sigma
okay,
bond, if all are sigma bond like that CH4, so hybridization is going to be what? sp3. Not able to understand.
yes, I understood.
Otherwise, you can go like that. The rule you can follow. There are many ways are there to understand. Not the only one way. There are many multiple ways are there. So
Yes.
hybridization is equal to 1 by 2 P plus M C plus A. 1 by 2 number of valence electron carbon is 4. Number of, if you're talking about monovalent, it is 3. Cation anion is not there. In this case, it is coming 3.5. 3.5 means round figure 4. Oh, wait. You cannot say 4. Here is this shortcut is sometime not working. This shortcut will not work. In this case,
So the earlier one was better. So the earlier one which we
that one you can do.
find out the firstly, sir, you have to find out the number of this ones or pi sigma bonds. So then you do that one.
For hydrocarbon only, there is trick. Single bond, all single bond, all single bond, all single bond is sp3. Okay, double bond, sp2, triple bond, sp. See, this is the single bond, na, sp3. Double bond, sp2, sp2. Triple bond, sp. Can you understand?
Sir, if both are there,
What?
sir, if both types are there. So for example, in benzene we have both single and double bond for one atom only.
But each carbon is what is there. Each carbon double bond is there. You go here. You say with this carbon also double bond is there, na? This one. This carbon.
Sir,
Any double bond.
so there
Any
is
double.
what about this one? So this one will have the double bond problem. So then what about this one?
Then it will be sp2. Hydrogen we are not taking, na. Only carbon we are going. Carbon. Carbon double bond. Anywhere carbon double bond is there. So it will be
Achha,
sp2.
hospital.
Hmm. Okay. Yes or no?
Yes.
Okay. So now this is there. What we can do? So this is one scenario. एक सेकंड से ना
Yes.
okay beta. Now what we can do here, this is all about the okay. So this is what we have done the aromaticity. See another compound I am taking. Okay, heterocyclic, heterocyclic, heterocyclic aromatic compound, heterocyclic aromatic compound. Heterocyclic aromatic compound. What is heterocyclic compound? They contain, they contain, they contain at least one carbon, at least one atom other than
Sir,
carbon and hydrogen.
what you have written at the top, sir, after aromatic?
Heterocyclic, hetero मतलब different. HETERO. Hetero means different. Hetero means different. And homo means same. Getting hetero means different. Odd is called hetero. So if any one is there, suppose this compound I am writing. Asa, slowly. Here is it. Nitrogen. Here is the lone pair electron. Now, this will be aromatic or not? This C in the center, what is there? Nitrogen is there. One is more is there. There. So they are having C lone pair also electron we have to add because it will be in the conjugation. See lone pair sigma pi. So this is the cyclic. Yes or no? This is the conjugation.
Yes.
They all are planar also. Planar.
Hmm.
Okay. And last one you are writing